Find the derivative of g of t equals 10 over the fifth root of t cubed minus 5 over the fifth root of t plus 3t minus 1 over the fifth root of 4. Then evaluate g prime of 1. G of t here is made up of 4 terms combined by addition or subtraction. 10 over the fifth root of t cubed minus 5 over the fifth root of t plus 3t and then minus 1 over the fifth root of 4. We can therefore take the derivative of each of those terms separately and combine the results by addition or subtraction accordingly. In order to take the derivative, we're going to make use of the power rule, but I will have to rewrite the first and second terms as a power function before we can attempt to take the derivative. G of t is going to be 10 over the fifth root of t cubed, t to the 3 over the fifth root, 3/5, minus 5 over the fifth root of t to the first power, t to the first power over the fifth root, t to the 1/5, plus 3t, and then minus 1 over the fifth root of 4. Now we can rewrite the first two terms by bringing the t to the numerator so we can make use of the power rule. It will move to the numerator by being a negative exponent, so 10t to the negative 3/5 and minus 5t to the negative 1/5 plus 3t minus 1 over the fifth root of 4. It's now ready to take the derivative. So let's do that. G prime of t equals. The first term is a power rule. We're going to bring down the power, negative 3/5, and subtract 1 from it. So negative 3/5 minus what I will call a 5/5 for the common denominator. The second term will follow the power rule. Minus 5 will bring down the power of negative 1/5. T raised to the negative 1/5 minus 1, which I will call 5/5 for the common denominator. The third term, 3t, is a constant times t. The derivative will be the constant, which is just the 3. The fourth term is all just a constant. It didn't have any t's with it. Even though it's a fraction and it has a root, there are no t's. It's all just a constant of some sort, so the derivative of that one is 0, and that's why I never rewrote that one. Let's simplify our derivative terms here. So g prime of t equals to, that 10 we can think of as 10 over 1, and we can multiply the numerators, negative 30 over the denominators, 5. T raised to the negative 3 minus 5, negative 8/5. The second term, I can think of that negative 5 as negative 5 over 1. Multiply the numerators, negative 5 times a negative 1 is a positive 5 over, multiply the denominators, 1 times 5 is a 5. And t raised to the minus 1 minus 5, negative 6 over 5, and then plus 3. Now we can take one more step and rewrite this where we move the negative exponents to the denominator to make them positive exponents. And also I can reduce the numbers, the fractions that are with them. The first fraction can reduce by a 5. That'll give us a 1 in the denominator, a 6 in the numerator. The second fraction also by a 5. That'll give us a 1 and a 1. So I have negative 6 t to the negative 8 over 5 plus 1 t to the negative 6 over 5 and then plus 3. Let's rewrite these to have positive exponents, we will move them to the other position, which is the denominator. Negative 6 over t to the positive 8/5 plus 1 over t to the positive 6/5, and then plus 3. There's our derivative, g prime of t. The next thing is to evaluate g prime of 1. That means to plug a 1 in for each of the t's. So we will have negative 6 over 1 to the 8/5 plus 1 over 1 to the 6/5 plus 3. We will have negative 6 over 1 to the 8/5. The fifth root of 1, which is 1, and raised to the 8 is, again, a 1. 1 raised to any power is a 1. Plus 1 over 1 to the 6/5. That means the fifth root of 1, which is a 1, raised to the 6, which again is a 1. 1 raised to any power is a 1. Anything divided by 1 is the same thing, so we will have negative 6 plus 1 plus 3, or negative 6 plus 4, which gives us negative 2.